Hello, my name is Sean Ditchko and welcome to this second video in a series showing how to analyze the velocity of a free-falling object using a spreadsheet. What you see in front of you is the finished product with a column with velocities that have random errors introduced to simulate measurements in the real world. We have a column showing our best fit line, which we're going to be creating on this graph of the data. So this green line is created using this column here. We have another column called chi-squared, which we'll talk about in a different video. It's used to do a sophisticated analysis using the computer spreadsheet functions. And we have some constants over here that help us do the calculations in these columns. The part we're going to be concerned with in this video is how to create this column with the measurements that simulate real-world measurements. We want to introduce some error. So we're going to forget about all these two columns, and we're going to forget about these two cells there, and we're not going to graph. This video will concentrate only on how to create this column here. You might wonder, why bother? Why do we want to have some data that has error in it? Scientists will actually do this when they're about to conduct an experiment so that they get a sense of what their data should look like. So if they're making measurements that do in fact follow some underlying theory that they have in mind, this is the kind of data that they'll actually expect to see in their measurements. Some data with some noise. This is also useful for you as a student so that when you're doing labs and you're making measurements and you don't see your measurements follow the theory perfectly, it's okay. What you should actually be seeing is some behavior that resembles the data in this column, which is easier to see on this graph here. You see some spread, some deviation from the best fit line, the green line there, which we'll create in a different video. So let's create this column of data. We're going to build the spreadsheet from square one, and we have a blank one over here. Let's put in a time column. We'll make it bold. Time, and always remember to put in the units, of course. We'll have the theoretical velocity, units of meters per second. And then we'll have the velocity with random error. In the time column, we'll go 0, 1, 2, 3 seconds, and so on. We'll highlight all of the cells there, and so that the spreadsheet can recognize the pattern that is going from 0 to 1 to 2 to 3. Grab this handle in the bottom right corner and drag it down. We want to go as far as 30 seconds, and we can see 27, 28, 29, 30 in that yellow box there. This column is going to have a formula in it. We'll need to copy over some constants from the finished product in order to make the formula. So we need the theoretical acceleration due to gravity of 9.8 meters per second squared and this theoretical initial velocity. Let's copy that and then paste it in this spreadsheet. We're also going to copy over the standard deviation, which we'll use in a minute. And then paste here. The formula we'll be using is this one, the kinematics formula VF equals V naught, that's NAUGHT for initial velocity, plus acceleration times time. That is the change in time. So we'll put a delta T there, the amount of time elapsed from whatever the beginning time was. Often the beginning time is time 0, and that's the case in our example. So we know that delta T is TF minus T initial, and we're going to suppose that T initial is 0. So we're going to rewrite this formula with just a T, since the initial T is 0. The acceleration is negative G. It's 9.8 meters per second squared downwards. And so we'll put a minus G here in place of the acceleration. So our formula is going to be VF equals V naught minus GT. So let's put that formula into this cell here. Select the cell and then type in an equal sign. And this declares that you're entering a formula into the cell after you type that equal sign. We're going to refer to this cell here, that's our initial velocity, and we just have to click on it, and the H3 appears in our formula. And that's going to be plus, so type a plus sign, plus acceleration, so we click there, multiplied by the time, which is in this column A. So we'll put that, click there. These two cell references to H3 and H2, we want to make them absolute cell references so that when we copy this formula down to the cells below in this column, this reference won't change. We want this formula to always refer to cells H, 2, and 3 for the acceleration and initial velocity. But A2 is going to change. When we copy this formula down, which we can do by selecting the box in the bottom right corner, when we copy it down, you'll notice that miraculously, this really smart spreadsheet has changed A2 from our original cell into A3 in the cell below. And that's exactly what we want. H2 and H3, though, have stayed the same because of these dollar signs, which make it an absolute reference. This reference to A4 is called a relative cell reference because it changes relative to whatever cell the formula is put in, whereas the dollar sign cell references are absolute, so they never change. So let's copy this formula right to the end. And now we get to the fun part, where we introduce some error into this theoretical data here. At this point, we're going to go to sheet 2, and I'll explain why we're going to do this on a separate sheet in a minute. We're going to have velocity with random error. We're going to use a spreadsheet function called norm SINV, and we're going to feed it a random number between 0 and 1. And this is going to look really mysterious, and that's fine. We're going to let it stay mysterious. Let's make sure we understand what our goals are. This is a tool that we're going to use to understand something else. We don't need to understand exactly how norm SINV works. Just like when you're constructing something and you use a drill, you don't need to know how the drill works. You just use it as a tool to finish some more important job. And your important job right now is we're creating data that has error in it. We want to see what does real world measurements actually look like when you consider error involved. So this function is going to do that for us. It's going to give us a number that we can multiply by the standard deviation, which is some number we invented based on our measuring tool. I guess the measuring device that we're using for measuring velocity has an error of plus or minus 5 meters per second. So we'll select the cell. We're also going to add that error to the theoretical velocity. So this could be a negative number as well, keep in mind. So it's going to be plus or minus some error. The reference to the standard deviation has to be an absolute reference, so we're going to put dollar signs in front of the J and the 2. Then we can copy this formula down to the bottom as far as we need to go. And I want you to notice that when we do any changes to our spreadsheet, like I type the number 2, for example, this whole entire column gets recalculated. It's 1.01 at the moment. I put in the number 3 into this cell. It's 0.27. I put the letter A here, and it keeps changing. So the point is, the way this spreadsheet works is whenever you make a change to a cell, it recalculates every formula in the entire spreadsheet. So that's going to be hard for us to work with if the numbers keep changing. And so we're going to copy these numbers. So right-click and then choose Copy, and take just these particular numbers and paste them into this column here. And we're going to paste special, because we don't want to paste the formula. All we want are those numbers. You're probably going to see the paste all checkbox selected, so remove that and remove everything else and choose only the numbers checkbox. And there we go. So what we've accomplished up to this point is that we've created a data set that has error in it to simulate what you would expect if you were to take real-world measurements. And a couple of other reasons why scientists would actually do this is they could use this as an elaborate hypothesis generating tool. So they could simulate an experiment first without going through the trouble of buying equipment and setting things up. They can just use a computer to create some predictions about what they'd expect to see. And they would want to have some error in these hypothetical measurements as well, just to really simulate if they did the experiment. So you can also imagine that an unscrupulous scientist could use these mathematical functions to cook the books, as they say, to create data that looks like it's been measured because it has this random error in it, but is actually just created by a spreadsheet function. Stay tuned for our next couple of videos where we show how to do a best fit line and how to do a chi-squared analysis to make sure it's the best fit line.